I'm going to put together a little video here. It's part of the Cummins engine build. But what this video is going to be about is going to be making a new air intake for the engine. Now, I'm not going to say it's going to be the permanent air intake. It's just a air intake that I'm building to kind of improve the airflow into the cylinder head. On the original Cummins, this is a plate that goes over the air intake on the head of the Cummins 5.9. So underneath this plate, the head casting is open, an open strip, and this is the front of it, this is the rear of it. And onto this, the grid heater sits, the grid heater being for cold weather use when it's cold outside. When you turn the ignition on, you let the grid heater warm the air up into the for the initial startup. And then on that, this is the air intake for coming off of the turbocharger or out of the intercooler. So you have this configuration. Now what it does is this plate, number one cylinder, is kind of like in this range, and number 5 cylinder is kind of in this range, and number 6 cylinder is in back from it. So what it does is, first of all, it restricts airflow into it, because this is approximately a 2.5 inch air intake. It restricts airflow into it, but the majority of the charge going into it is towards the front of the engine, and it kind of restricts airflow to number 5 and 6. That's kind of a historical thing with 5.9 Cummins. Also, number 1 cylinder is kind of restricted too, but that's a different issue that I'll address later. So what I did was made a plate to replace this one, but yet keep the grid heater in it. The guy wanted to keep the grid heater in it because he's probably going to be driving the truck in the winter time, so he wants a grid heater in it. So what I've done is made a plate with two, it is going to have a 3-inch OD into it, and have 2 separate air chambers, one towards the front of the engine, one more towards the rear of the engine. Now the grid heater, of course, is only going to set in one of them, but it should provide enough warm air charge for that initial startup during the winter time, even if the guy is going to use it in the winter time. So here's what I did: was took a piece of steel, transfer punched the holes into it, milled the holes out, and then laid out where I wanted it and built this. Now, as I said, I don't think this is going to be the permanent one. It's going to be, this is my first attempt at building one of these. In hindsight, I probably would have radiused the corners off of it, curved it to make a more a better airflow to it than straight corners on it, more curved or a linear airflow into it than the straight corners on it. But again, it's going to have much more air going into it than the original one. Now, the Cummins build is ongoing. We have put performance pistons, performance cam, bigger valves, stuff into it. But the guy is kind of running out of money to get a bigger turbo and a upgraded P pump for it. So the real horsepower is yet to come. And when that does come, so I'm going to build the engine without that. We're going to put the original turbo that was on the engine back in the original P pump. So the guy is going to be restricted to what the turbo will put out, what the P pump will put out. At some point in time, he's going to be putting a bigger turbo and upgraded P pump on it. It's going to deliver more fuel. At that time, hopefully what I can do for him is improve this. I'm actually thinking of making this out of aluminum and making a domed single airflow into the cylinder head with one like 4-inch inlet into it, but it would be, the open area would cover the entire open area of the head for the air intake, instead of having the two holes in it. The whole thing would be open. So that will be to come, but what this video is going to be about is showing how I built this and why I built it and that. So I'll bring you back for the remainder of it. Figured I might as well shoot a little bit of this. I'm just drilling pilot holes in this plate. This plate is going to be the base plate that goes onto the air intake for the Cummins. These holes don't appear to be lined up. I have to keep readjusting the y-axis on this thing, and the vise is pretty close. I mean, it's off maybe a thousandth over it, but every time I go from hole to hole, I seem to have to adjust the y-axis on it, so they don't seem to be lined up too well. I kind of find it easier to turn the mill off when I'm trying to center it over the punch mark. Now, you'll probably see as I move the table down, I might have to adjust the y-axis. This one isn't bad, probably a couple of thousandths I had to do it. Now see, this one I've got a head to adjust the X. Let me find out what the bolt sizes are, and I'll bring back. I didn't put that tape on there. It was on the bit to begin with. Just kind of laying out, I've got the holes all drilled into this thing. Originally the intake manifold has one port on it, and the port is restricted by the grid heater that goes into it for kind of warms the air as for winter starts. So you get kind of a warm charge put into the engine on cold days. It's restricted because of that, but it's also restricted on the inside of the intake manifold. Let's not call it, figure out something to call it, but anyways, here it is. What I'm going to do is put two of them in. So the grid heater is going to go in one. The other one is going to be piped up directly. Now, do you really need a grid heater in the wintertime? Yeah, you probably do, especially on older Cummins, but if you plug the truck in to begin with, or have it plugged in on cold days, when I say cold days, I'm talking probably 15 degrees or below. But if you have it plugged in, you're probably not going to have an issue with it starting without a grid heater. But he wants to keep the grid heater in just in case, so I'm going to put it on the one port of it. So realistically, it's only going to have half the efficiency of the original one. So, but I think it'll be sufficient to make it work. So what I'm going to do is just kind of lay out the other ones. I take the center of the two holes because I'm going to have to create a flange to sit on this one. This intake runner will come over here, so there will be it'll come in, it'll be center fed, split out at angles, and then fed into this and into this port. because we have a grid heater on this one, I've got to raise it 2 7/8 inches on this one, make the runner longer to fit it. And what I'll do is I'll build flanges that can fit on this, and I'll build a flange that can fit on this, so you can actually unbolt the intake horn off of the intake plate for the top of the head. What the two of them are going to achieve is better airflow. Older style Cummins notoriously have an issue with airflow up to number 1 and somewhat number 2, number 5 and number 6 cylinders. So this is going to kind of disperse into 2 sections where the airflow is coming into it, and provide more airflow into it. Instead of having, this thing is approximately 2.5 inches square, the internal part of it. It's actually a little bit longer this way, but what I'm going to do is make 2 2.5 inch ports going into it. So we're going to get better airflow. We'll get better airflow through this because of the way it was restricted to begin with. It's kind of a very restrictive type of thing. Not as restrictive as some of the newer ones, but restricted. But we'll get better airflow into it. Get a lot better airflow on 5 and 6. And hopefully between the combination of this one and residual air from the back one, we'll get better airflow forward too. We'll get better airflow forward because the port is actually positioned a bolt hole set in front of the original port. So inside of that intake runner on the head, there is some casting bump outs in it that restrict the airflow in it, besides the restricted size and grid heater. There's also some things that kind of stick out inside of the thing, so the air gets kind of choked down, expands back up. There's another big one over in here, a restriction in the casting, and the air has got to really go around to get into number 1 cylinder. So hopefully this will provide a lot better for it. But I kind of digress here and got off the point. Where my lights went out. bring it back. You probably aren't interested in seeing all this. So here's a plate with the 2 holes cut in it. I took it over to the mill and cut them out with an end mill. I just plunged it in there and then went around it, you know, just move the bed in the X and the Y axis and cut the square out to the scribed lines. So there it is. Now I'll bring you back when I continue to do some work on it. What I've got to do now is probably get the flange plates made up that's going to fit on the tubing. So what it'll do is it'll come out like this for a little ways and then 45 off. It's actually gonna be, that's that mock-up one that I did. So it'll look like that, except it will have the grid heater in it. Don't look at those welds. That, again, that was I just MIG welded the thing together to make sure to see what kind of issues that I would have in TIG welding it out. So that's it. But that's what is going to be on this thing. Bring it back.